What is big data's role in rare leukemia research? Imagine trying to solve a puzzle with only a few pieces. That's what researching rare leukemias can feel like because there are so few patients. Big data changes that by gathering huge amounts of information from many sources. It helps researchers see the full picture, even when individual cases are scarce. Rare leukemias are uncommon types of blood cancers that don't happen often. Because of their rarity, traditional studies often don't have enough patients to draw clear conclusions. Big data involves collecting and analyzing vast datasets that include genetic information, medical records, lab results, and how patients respond to treatments. When these data come together from different hospitals and research centers, scientists get a much clearer view of these diseases. Using advanced computer tools like machine learning and artificial intelligence, researchers can analyze complex data patterns. For example, they can look at genetic mutations and gene activity to understand what drives these rare leukemias. This helps identify biomarkers, specific signals in the body that can point to the disease or predict how it will progress. It also supports personalized medicine, meaning treatments can be tailored to each patient's unique genetic makeup and disease characteristics. Big data also improves diagnosis. Artificial intelligence models, especially deep learning techniques, can analyze images and lab results to detect leukemia more accurately and quickly. This is especially helpful for rare subtypes where early diagnosis can be challenging. Another exciting development is synthetic data generation. Because patient data for rare leukemias is limited and protected by privacy laws, researchers can create realistic fake datasets using generative AI. These synthetic datasets mimic real patient data and can be used to test new ideas or run clinical trial simulations without risking patient privacy. Big data also helps combine different types of molecular information, called multi-omics data. This includes genomics, transcriptomics, and proteomics, which reveal the molecular complexity of these diseases. Analyzing this information can uncover new biomarkers and potential targets for therapy that traditional methods might miss. Predictive models built on large datasets can also forecast how patients will respond to specific treatments. This helps doctors choose the most effective therapies and avoid those that might not work, reducing side effects and improving outcomes. Collaborative efforts like the Harmony Alliance show how sharing data across countries and institutions accelerates research. By pooling resources, scientists can ask bigger questions and find answers faster, ultimately leading to better treatment options for patients with rare leukemias. Of course, challenges exist. Data can be inconsistent or incomplete, and privacy concerns must be carefully managed. Researchers are working to standardize data collection and improve AI transparency so that findings are trustworthy and useful in clinical settings. In summary, big data is revolutionizing how we understand and treat rare leukemias. It helps us detect these diseases earlier, diagnose them more accurately, personalize treatments, and discover new therapies. While there's still work to do, these advances hold great promise for improving outcomes for patients facing these uncommon but serious blood cancers. Always remember, if you or someone you know is affected, consulting healthcare professionals is essential for personalized advice and care.